Now we have another example. So to obtain a high pass, we need to shift the pass band from 0 to pi. Hence we get the omega null is equal to pi. We will choose p equals to 0. And the modulation function is going to be 1 divided by pi times cosine of pi times n, which is simply a sequence of plus or minus 1. So here we are defining our low pass. So this is the ideal low pass we are defining. Then we are multiplying the ideal filter with a Kaiser window, the same principle like we did before. So we are using the window method to design a low pass, and then we are going to use modulation to transform this low pass into a high pass. So how can we make a high pass out of this low pass using modulation? We are going to multiply our filter by the cosine of pi times n, like we're doing here. And here is the impulse response of the modulated. So this is, we will see that we can see the effect of modulation with the plus or minus 1 sequence, and the resulting frequency response, when you'll see the frac Z, we have now a high pass filter. So we designed a low pass using the window method, then we just use modulation to transform the low pass to a high pass. And we see that we indeed obtain a high pass. So it basically looks like a mirrored around the center. In reality, it's shifted, but what we see as the high pass part was the negative frequency part of our low pass. We can also obtain a band pass if now the center frequency will be pi divided by 2. So we are multiplying our low pass filter with this modulation function. With the center frequency is pi divided by 2, and we see we have a band pass. But observe that we obtain a band pass that in this band pass case, in which is twice as wide as the case of low pass or high pass, because here the negative frequencies of the low or high pass can appear as the other half of the pass band. So when you are going to use modulation, you need to design the low pass, and then you must adjust the bandwidth, so the pass band of the low pass, and the center frequency of the modulation function, so you can achieve the desired characteristics of the band pass. We see that in this case the band pass here is twice as wide. Maybe we don't want this, so what we can do is that we can make the low pass, we design the low pass, and the cutoff frequency would be half perhaps of the what we would design for a normal low pass, and then when we modulate we'll have the desired band pass filter. So that's it for this notebook, and I see you next time.